This is a short video exploring the pharmaceutical and chemical aspects of DMT, dimethyltryptamine. It should be noted that this is for educational purposes only, and in no way does this video condone the synthesis, extraction, or experimentation with a Class 1 scheduled drug. First off, let's explore some of the neuropharmacology. That is the backbone for understanding how these drugs can work. The human brain is a complex neural network consisting of over 10 to 100 billion cells. Each of these cells has a very complex interaction with each other. This complexity can be broken down into two levels. One level, the lower level, is thought of as the fast-acting synaptic level. This level operates our basic biological functions. It just sends the message to the rest of our body. It operates basal actions. The second level, which then operates the first level, is complex in the sense that it is operated by the way we experience our environment. So, for example, serotonin. Disequilibrated serotonin levels can lead to many different disorders, like depression. Acetylcholine is disequilibrated in Alzheimer's. Dopamine is disequilibrated in the addictive process involving the nucleus accumbens, which is part of the brain. But what we're going to look at right now is the interaction of serotonin with our brain with respect to DMT. By understanding the molecular structure of serotonin, we are able to understand how hallucinogens work. DMT has very few structural differences from serotonin. It is part of a class of molecules called tryptamines, which you can see in the list below. What this means is that by understanding the structural similarities, we are also able to infer the receptors of which these small neurotransmitter molecules bind. The receptor classification of DMT was elucidated by Rick Strassman. Let's take a little history lesson. Back to 1991, Rick Strassman and his colleagues were studying DMT's effects in 12 volunteers who were experienced hallucinogen users. Volunteers got several different doses of DMT and were all uniformly overwhelmed at the effects. Once the effects of DMT were characterized in the group, Strassman started to design more studies. One study attempted to block the 5-HT1A receptor. It was blocked with a drug called N-Dimethyltryptamine. He basically compared people's biological and psychological responses to DMT alone with the responses to DMT after the receptors were blocked. He found that, quote, the psychological effects increased when the 5-HT1A site had been blocked with N-Dimethyltryptamine. He concluded that stimulating the 5-HT1A site acts to buffer the effect of unrestrained 5-HT2 activation. So what does this mean? It means that DMT works through the 5-HT2 receptor, as with most hallucinogens. To conclude our short neuropharmacological study of DMT, we will look at the actual levels of DMT in our body. The following slides contains speculative information with regard to DMT. It is thought to be endogenous in the pineal gland and is released during dreams and near-death experiences. It is also used as teas in shamanic rituals. For the second part of our exploration of DMT, we will look at the extraction chemistry. It must be noted that even attempting this process is highly illegal in the United States. The following is a basic acid-base extraction. By adding acid, you're able to turn DMT into its aqueous form, or sulfur. Again, by adding a base, you're able to turn it back into its organic, free base form. The process begins by grinding out the root bark into a fine powder. The purpose of this grinding is to increase the surface area. That fine powder is then placed into a large bowl, and water is then added, as well as hydrochloric acid. The purpose of the hydrochloric acid is to turn DMT into its solid form, so that it can dissolve into the aqueous layer. solution of rhubarb powder, water, and acid is then filtered. The rhubarb powder that remains in the filter can then be reused. Multiple extractions can be done with the same powder. DMT is now concentrated in the filter. It exists as its aqueous or salt form. The next step is to add sodium hydroxide. Sodium hydroxide functions to freebase the aqueous or salt form of DMT. This form of DMT is now able to be soluble in the organic phase of the solution. A dramatic color change can be seen as sodium hydroxide is added to the filtrate of DMT. It must be noted that the jar becomes very hot at this time, and if the base is added too quickly, splashing could occur. The jar is now filled with the free-based form of DMT. The next step is to add an organic solvent, naphtha, to the jar. After naphtha is added, the jar can be shaken out. It takes about 5 minutes for the emulsion to settle, and then the aqueous phase and the organic phase can be clearly separated. After the two phases are separated, the organic phase can be removed with an eye drop. The resulting organic phase is concentrated with dimethyltryptamine. This organic phase can be placed on a flat surface in order to evaporate. As the solution evaporates, crystals will be left over of dimethyltryptamine. This concludes our short exploration of DMT.